On this video, we'll be discussing division of whole numbers and the sequence we use to accomplish this algorithm. You might be wondering what a cheeseburger at McDonald's has to do with the sequence of division, but there's something called a mnemonic phrase or an expression, and it's a weird thing that we might remember that helps us remember something else. In itself, it doesn't mean anything, but if we remember it, it can help us remember an important thing. So the little phrase that we use to help us remember the division sequence is a simple question. Does McDonald's sell cheeseburgers? Doesn't make much sense by itself, but let's just see how it fits into the division sequence. When you divide, you have to do 5 things, and they have to come in a special order. The first is divide, and that's what the does in the sentence or the question has to do with division. First we divide, then M multiply, then S subtract, C in cheese for check, and B in burgers for bring down. That might not mean much right now, but hopefully as we go through this video, it'll make more sense. Okay, here's a simple division problem, an algorithm. An algorithm is a process by which we do a math problem, and it has to have a certain sequence, and a sequence means that something comes first, something comes second. Okay, well, in this particular problem, we're trying to find out how many 7s can be taken from a large group of 368. Now, we don't have to do it all at once. We can do it one place value at a time. First of all, we can check out the hundreds place here where there's a 3. And simply ask ourselves the question, can we divide 3 by 7? Now, a way to help you answer that question would be to say, are there any groups of 7 in just 3? And the answer to that question is no. So we can take the 3, put it with the next place, the tens place, makes the number 36, and ask ourselves the same question again. Is it possible to take any groups of 7 from 36? And the answer to that question is yes. You can take 5 groups of 7 from 36. So in a way, we've done division by asking ourselves a multiplication question. But we've been looking for the missing factor in that multiplication problem. So we have divided 36 by 7 and found that the answer to that is 5, which we put in this place. And then the next step in the process is M. Does McDonald's sell cheeseburgers? M for multiply. And we need to multiply because, in essence, what we've done is we've already said that we've taken out 5 groups of 7. And rather than going into, as a lot of people say in division, it's really makes more sense to be a process of taking away. So let's take away those 5 groups of 7, but first of all we have to know what that value is, and 5 times 7 is 35. So the 5 groups that we took out, we need to subtract that value from what we started off with here. Okay, so that would leave us with the next step in the procedure, subtraction. And when we do subtract, we find that there is 1 left over. Okay, now the next thing in the procedure says to check. Okay, well, what does that mean? It means to check and see if what's left over is enough to allow us to take any more groups away, in this particular case, groups of 7. Well, we know enough about numbers to know that there's no way that you can do that. 1 is way too small to take a group of 7. So what does that mean? It means that we've taken all the groups up to the tens place that we possibly can. A lot of times we might stop and ask the novice, the person just starting off in division, well, how many groups of 7 have we taken so far? And most often they might say 5. There might be a few people, though, that will give the right answer. It's actually 50. We've taken 50 groups of 7 out of this number 368. And the total of 50 groups of 7 is 350. We just don't see the 0, but we know all of that because of the places that they're filling. Okay, we have 10 left over, or 1 from this place, from the tens place. Okay, we've checked. We can't get any more groups of 7. So that means to go to the next place. That's the signal once all that's been done, and bring down the digit in the next place, which happens to be an 8 in the ones place, now making 18, still remaining in the pot to make groups of 7 from. Okay, well, here we are. We've done all of the 5 steps. We're not done because we have to repeat the process with every digit. Okay, here's the problem as far as we have it right now. Okay, now we're looking at 18. We need to divide it by 7. Okay, we ask ourselves the question, is it possible to take any groups of 7 from 18? Well, yes it is. And if we know our 7's table, we know that we can take 2, but we can't take 3. So 7 divided into 18, or 18 divided by 7, is 2. Because when we do the next step, multiplication, which in a way we've already done in our head, 2 groups of 7 is equal to 14. And now that we have taken those 2 groups out, which equals 14, subtraction will tell us what we have left. And then we need to check to see if it's possible to take any more 7s away, and with an easy problem like this in a very small group, we can easily tell the answer is no. 4 is way too small to take a group of 7. So what do? Well, the next step would be to bring down, but whoops, there aren't any more places. Well, it basically means we're done. Now, in the upper intermediate grades, when you get into 5th and 6th grade, beyond 4th and beginning of 5th, there'll be a decimal point that can be put here, and you can add places in. That we'll talk about on a different video. It's a little bit more advanced. But now, we just say that's the remainder. That's the pot left over. Okay, well, let's check the sequence here with larger numbers. Does it work with them also? Okay, I'm going to go through the sequence. I know in many cases it's still not going to make sense, but I'll show you how to work it out as we go on in this video. So we don't want to forget that we have a sequence, no matter how difficult the numbers. Does McDonald's sell cheeseburgers? Or in other words, we need to divide, multiply, subtract, check, bring down, till we get to the very end of the problem. Okay, we have a big number here, 36,893. And we're asking ourselves the question, how many groups of 47 can we take out of this? And then what will be left over? Well, to start off with, if we take a look at this 10,000ths place, just the 10,000ths place by itself, which is a 3, is not large enough to allow a 47 to be taken from it. In fact, if we go to the next place, include the 10,000 and the thousands place together, for the number 36, that's too small to take 47 from. We have to go all the way down here to the hundreds place and use the number 368 and ask ourselves, because this is large enough, how many groups of 47 can we take from that? Now, that's a difficult question. And it's okay to guess. There are ways of making educated guesses, and it's a little trick that I'm going to use right now, and I'll fill you in on it later on. Okay, my guess is that there are 7 groups of 47 in this number 368. I can prove that when I do the next step, multiply, which in a way I've kind of already done that. You'll see why in a second. Okay, when I multiply 7 times 47, I get the number 329. Okay, and that's good. I'm happy with that so far. It's a number that's smaller. I didn't go over this number, so it's possible to take 7 groups out. When I subtract and check, subtract first, I'm going to get this number, 39. Now the check will tell me, as I compare the 39 to the 47, 39 is a big number, but it's smaller than the number in the groups that we're taking out. Not big enough to take another group of 47. So that means I go to the 9 in the tens place, bring it down, and now I have the number 399, which once again I'll ask myself the question, how many 47s can I take from 399? Okay, I'm using my little trick, and I'm guessing 8. Okay, when I multiply, see, I'm starting the sequence over again. My division guess, or it's an educated guess, it may be wrong. If it's wrong, the multiplication, subtraction will tell me that. Okay, I'm now multiplying 8 times 47, and I come up with the number 376. Okay, that's good. I didn't go over this number. That means I didn't pick too many groups of 47. Okay, I'll subtract to see if it's possible that I didn't guess high enough and that there's still enough left over. But when I subtract and I check between the two numbers, the size of the groups I'm taking out and what's left over to take more groups from, there is too small an amount here to take another group of 47. So I've taken every one that I possibly can out of this. Okay, next in the sequence, and there is one more place, bring down the ones place. Now we started off with 36,893. So far, if you take a look at the places that this answer is in, called the quotient, so far we've taken 780. That's blank, so we'll picture a 0 there. 780, that's a lot, groups of 47 away from this very big number. All that's left to deal with now is 233, and we have to ask ourselves the question and then do the sequence all over again. How many groups of 47 do we think we can take from 233? And my guess would be 4. Okay, now I have to check and see if my educated guess here is correct by doing the multiplication. 4 times 47 is 188. And the subtraction, 45 is left over. Well, I wasn't right by too much, but the check shows me I was right by enough. 4 groups is all that can be taken, because when you take them, only 45 is left over. That's too short of what you need to make another group of 47. So, there's nothing more to bring down. We've reached the end. We're not using the decimal point and creating the places over here yet. So 45 becomes what we call the remainder, the part left over, the part that isn't big enough to make a group, the remainder of 45.